Assalamu alaikum wa rahmatullah. Welcome back to our chemistry class SS2 prepared by Abdul Hamza. Content: we're going to see halogen today, electronic configuration of halogen, the electronic configuration, some property of halogen, uses of halogen. Halogen are grouped in the periodic table consisting of 5 chemically related elements. So the elements in the halogen are chlorine, bromine, iodine, astatine. The word halo means salt former or salt maker. When halogen react with metal, they produce a wide range of salt. Halogen give a charge of negative, so they give similar formula, e.g. sodium bromide, sodium iodide. So what it means here, halogen can accept one electron from the metal, especially group 1, to form to form a metal chloride, bromine, iodide, or astatine. Halogen react vigorously with metal to form ionic salt. For the equation, 2 calcium react with molecule of bromine to give potassium bromide. So halogen become less reactive down the group. So this means chlorine react better than chlorine. Chlorine react better than bromine. Bromine react better than iodine. Iodine react better than astatine. So going down the group, bromine become less reactive. So let's see the electronic configuration before we see the electronic configuration of halogen. So electronic configuration is basically the arrangement of electrons in the orbital of atom. There are certain principles accompany that when writing the electronic configuration of any element. The principles are Pauli explosive or Pauli principle. So Pauli states that all 4 quantum number of any 2 electrons in the atom cannot be identical. So what we mean by quantum number is the direction of electron in the orbital. So orbitals are nothing but we have how many types of orbital? We have S, P, V. So what they mean here is in S orbital. So the direction of electron feeding in the orbital must not be identical. That means the first electron is facing off and the second electron is facing off, cannot accommodate that. What Pauli is saying, when the first electron enter into the orbital is facing up, then the second must face down. So in the S orbital accommodate only 2 electrons, while V orbital accommodated 6 electron. We have 2px, 2py, and 2pz. So in 2px accommodate 2. Okay, px accommodate 2, py accommodate 2, pz accommodate 2. So in each orbital, p orbital divided into 3. So each the xpz, none of the electron can have identical quantum number. So that is what Foley trying to let us understand. Then we have Hall's principle. Hall's principle states that electron can get pair up in an orbital only when all subshell consist of at least one electron in it. So what Holmes is trying to teach us is that when electron entering into a orbital, for example, S orbital is accommodating only 2 electrons. So in P orbital, what is trying to teach us is that when electron entered into px electron, then the next electron entering the orbital must enter 2 phi z, 2 phi y, and then 2 phi z before it come and fill the x orbital. That is the one that is going the opposite direction. So that is what Holmes is trying to let us understand. Then we have Abbo principle. Abbo principle states that electron of any element can fill energy level in increasing order. So what he means here, electron entering, when electron must fill 1s orbital before go into 2s orbital, 2p orbital, 2p orbital, 3s orbital, and the rest. So that is what Abu is trying to let us understand. So let us see the electronic configuration of halogen. In halogen, the first element is fluorine. So fluorine is fairly yellow in color and is diatomic and it is gas at room temperature, which is highly toxic and corrosive in nature. It has the atomic number of 9. It belongs to second period and it is located in the p block electronic configuration of fluorine is 1s2, 2s2, and 2p6. And 2p5. Sorry, here is 2p5. So what they mean here is belong to the second period. So we will go back to electronic configuration of element. Element has it has certain number of period which is called K, L, M, N, L, and the rest. So in K shell accommodate only 2 electrons while the rest accommodated at 8 electrons. So what they mean here, what they say fluorine belong to second period. So the 9 electron in the fluorine, when entered, 2 of the electrons entered into K shell, and the remaining, that is 7, will enter into the N shell. So fluorine has K and N shell. That is why they say it belongs to the second period. So the electronic configuration of fluorine is 1s2, 2s2, and 2p5. Then the second one is chlorine. Chlorine is a greenish yellow color, and it is a gas with a very strong smell. It has atomic number of 17, belong to P block, third period in the electronic and the electron configuration of chlorine is 1s2, 2s2, 2p6, 2s2, 3p5. So when we see chlorine, it has color. When we see chlorine, it's greenish yellow, and it is a gas with a very strong smell. It is also diatomic. What they mean here, chlorine exists in 2 of its form. You can never see chlorine. You cannot see chlorine in its atomic form. It reacts with self because it's very reactive. That is why it exists in the atomic. So in the electronic configuration of chlorine, we see we have KLM shell. That is mean they has 3 chlorine. It has 3 shell. It belongs to that period, and it is P block. When in writing the electronic configuration of chlorine, we see it will end up in P orbital. That means it has P. It is the last orbital is 3p, and it has only 5 electrons in it. So that is what it means. Then let's see bromine at room temperature. Bromine is reddish brown color. That means bromine, it is also colored. Bromine has atomic number of 35 atoms, situated in the 4th period, and P block. It has the following electronic configuration. That is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 5s2, 5p3, and that is bromine. When bromine melt, it change color. That is what they mean at room temperature. As at normal temperature is reddish brown, but when heated, it will change color. Then we have iodine. The therefore of iodine gas are violet color. So we all know that halogen, they are gases. So the level of iodine is colored. The color is violet. Iodine has 53 atomic number and belongs to P block, fifth period. Electronic configuration of bromine is 1s2, 2s2, 2p6, 3s2, 2p6, 4s2, 3d10, 2p6, 5s2, 4d10, 5p3. So this is the electronic configuration of bromine. Then halogen have some unique property. So let us see those property that halogen has. So all halogen molecules are diatomic, all of them, from fluorine to astatine, that is down the groove. They can get electron by reacting with an atom of other element. So that means all the halogen are looking single electron to become octet. So they react with one electron from the other element, especially metal, to become halogen have 7 valence electrons. Therefore, they form negative ion that is highly reactive. So halogen have 7 electrons in its outermost shell. All of the halogen they have 7 electrons in their outermost shell. That means they are looking for only one electron, and it forms negative charge. When element accept electron from others, it form negative. When it give out, it become positive. Fluorine is one of the most reactive elements to exist. So among the all elements, fluorine is the most reactive element. Halogen have strong and nasty smell, as we see in the front. So halogen are toxic. They are toxic in nature. Even in the organic compound, when we see organic compound containing halogen, e.g. fluorine or chlorine or any other, that compound, it has toxicity. So the toxicity of most of organic compound is due to the presence of halogen. Halogen have low melting and boiling point. They have low melting and boiling point. They can easily melt and boil at a small amount of temperature. So they are poor conductor of electricity, of heat and electricity. All the halogen are poor conductor of heat and electricity. So let's see some uses. Small amount of fluorine are used in water and toothpaste to prevent tooth decay. So in the industry, they are using fluorine in the toothpaste. This fluorine used to prevent teeth from decay. Iodine is used to clean wound and cut, and is act as disinfectant. So iodine is disinfectant. Astatine has found use in medicine, although it's radioactive decay. So, astatine are used in the medicine. So, this is the end of today's lecture. We shall meet in the next class edition. Thank you for listening.